Okay, we're moving on to section 12.5. And we're talking about the normal distribution. And this involves using information about mean and standard deviation to determine the percentage of values, data values, that are between two levels. So the first problem we're doing is problem number 8. And it says that we have 100 students, which we don't use that in the calculation. That just goes to show that it's a sufficient number of samples, that the standard deviation and the mean are sufficiently accurate. So the mean, which we show as x bar, is 86 grams. And the standard deviation is 1 gram. So over here on our normal distribution, we have these spaces. The middle space is for the mean. So these are z-scores. So this is z equals 0. At z equals 0, you're at the mean value. The standard deviation is 1. I'm going to leave the units off for right now. So for a z-score of 1, it means that you are 1 standard deviation more than the mean. So one standard deviation is just 1. So this is going to be 87. This could be 88. This is 2 standard deviations more than the mean. This is 3 standard deviations more than the mean. Then you go the other direction. You're 1 standard deviation less, 2 standard deviations less, and 3 standard deviations less. And we haven't actually plotted the data. All we're told is that it behaves as a normal distribution, and it approximates this. And if you have an infinite number of data points, it should end up being a pretty normal distribution, pretty normal distribution. So most of these problems will give you the mean, the standard deviation, and then you could calculate what these are. You don't need to fill it in. I'm just doing this to try to make sure you understand what's going on. So what we try to do is then take the questions they're asking for it and represent them by what they are as the area underneath the curve. So number 8 says that we want the percentage. So what it actually asks for is percentage. Use symmetry, blah, 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 to find the number of estimate the number of students. So since there are 100 students, all you really need to do is find out what the probability or the percentage of 100 students that will satisfy the requirements, in this case more than 85 grams. So we've got our generic normal distribution. More means we only have to draw one line. If it was between, then we would do that. Now, it turns out that 85 represents that vertical line, because that's, if you calculate the z-score for 85, so I'm going to put z sub 85, that's x minus x mean over s. In our problem, x is 85, which is this number. Subtract the mean divided by the standard deviation, and you get -1. 85 minus 86 is -1, divided by 1 is -1. So that's the z-score. And so since I have both the z-score and the actual numbers, they should match up, which they do. And so they're saying greater than, which means to the right of this. So what we have to do is figure out what is the area underneath this curve to the right of this vertical line. Well, because the starting point is to the left of the line of symmetry, what we can do is we know that anytime you have half of the curve without it being cut at all, so if we do this with blue, the blue is the area above 86, which is the mean. And always half the data is above the mean. So what we can say is that the area of, we could say 86 plus, meaning the area from 86 to the right is going to be equal to 0.5, because if we had this half, that would be 0.5, and the other half is 0.5. To find the total area, what we need now is to find the area for the remainder of this problem, which is the green area. Now, because of symmetry, this green area would be the same as if the line were over here. So this line can be moved over there, and we can look at the area in that curve. And that's what the curve in the book is asking for. So even though our z-score here for 85 is -1, what we do is we want to find the area associated with a z-score equal to, we want to find it for -1, but because of symmetry, it's also the same as if z equals 1. So z equals 1 is used in the table. So we go to the tables on page 671. We look down the rows, and the second column of z's, you go down all the way down almost to the bottom, and you see z-score of 1, and it has a corresponding area of 0.341. So the area for the green part, 0.341, plus the blue area gives us a total area. So what we can say is that the total area, which is what we're trying to find, is the area for the half above 86 plus the area associated with the z-score equal to -1. So all we have to do now is just plug the numbers in. So we have let me do it in blue. So we have the blue area, which is 0.5. We have the green area, which is 0.341, and you add those two together, and you get 0.841, or 84.1% of the values are above 85. So 84 out of 100 students have values above 85. And yeah, so 84 comes from here. 85 comes from the problem statement. Okay, so let's make a copy of this thing here, and we'll do the next one. Yep, something happened. Copy. Paste. I don't know why sometimes it works and sometimes it doesn't. Clone. Okay, move it over there. One more time. Okay, so we'll work on that in a second. Okay. So the next problem is 12. So we need to know what the mean and the standard deviation are. So it says we have IQ tests. The mean is 100. The standard deviation is 15. And they're asking us for the percent of people whose IQ falls into each category. So our category for 12 is greater than 115. So let's fill out this picture. So the mean is 100. The standard deviation is 15. So at a z-score of 1, that means we're 1 standard deviation more than the mean. And then you just add 15 on to all of these. And then you subtract 15 So you don't get negative 85, you just get 85. So 100 minus 15 is 85. 85 minus 15 is 70. 70 minus 15 is 55. Okay. So those are all the information we need. We have the z-scores from the standard distribution. We have the specific data. We now draw a vertical line to represent that particular value, which is 115. So if we didn't write these in, if we just wanted to do it based on z-scores, we'd say the z-score associated with 115 is going to be 115 minus the mean divided by the standard deviation. So you get 1 again. 15 divided by 15 is 1. In this case, you're 1 standard deviation above the mean. So that is the vertical line at z equals 1. And what we're looking for is this area here, which is greater than, because we're greater than is to the right. So we're looking for that little slide there. But the thing is that our table gives us information of area from the mean. So we can get that. We just got that as 0.341 because it's the same. So how do we get this area knowing this is 0.341? Well, the total area from the middle to the end is 0.5 because half the data is on this side, half the data is on this side. So if we take 0.5, which is the total area, we subtract the blue area, that'll leave us with the green area. So let's just write that out. So what we're going to say is the green area. So if the area for greater than 115 is equal to the area for, let's say for half, that's this whole part, and then we subtract the area associated with the z-score equal to plus 1, because that's where our line is. Your z equals plus 1. Again, this black number is 0.5. The area associated with the z-score 1, we've already looked that up in the previous problem. Only here we have negative 1, which is the same because the symmetry is positive 1, is 0.341. So total area is 0.5. This is 0.341. This one's going to be 0.5 minus 0.341. And that is 0.5 minus 0.341, 0.159, 0.159. Therefore, .9% of the data, which in this case is IQ, is greater than 115. So if your IQ is above 115, you're in the top 16%, basically. So let's go to the next one. I'm going to move that over. Okay. So our next problem is 16. So 16 says find the percent of area under normal curve between the mean and the given number of standard deviations from the mean. So in this case, they don't give you the mean and the standard deviation, but they do give you the number of standard deviations. So for example, I'm just going to quote all 4 of them just to tell you what they are. So problem 15 says 1.5 standard deviations. What that means is z equals 1.5. For 16, we have the 0.92 standard deviations. So what that means is z equals 0.92. Number 17 says negative 1.92 0.08. So the z-score is negative 1.08. That's all the z-score is. It's just the number of standard deviations either above or below. And you get 2.25, and that's z is equal to negative 2.25. Okay, so that's how you go from percent or number of standard deviations to z-score. It's the same number. So it says find the percent of area under normal curve between the mean and the given number. So what they're asking for is the distance or the percent between the mean, which is this line, and a z-score of 0.92. So that's going to be right here. Now I don't really know, I can't fill in the lower numbers because I don't have them, but I do have the z-score. So I know what they're asking for is the area between the mean and a z-score of 0.92. So how do I find that? Well, that's exactly what's in the table. So what I say is for z equals 0.92, the table says that the area, so we go into the second set of numbers, starts at 0.56 and ends at 1.1, and we go to 0.92, which is, we look at the corresponding area, which is right to the right of it, 0.321. Okay, so the area is 0.321. So what does that mean? Well, it says find the percent. So to go from the area associated with the z of 0.92 to a percent, you just multiply by 100. So 32.1% of the data is between the mean and a value 0.92 standard deviations greater than the mean. Okay, so we're going to stop there. We'll continue on this.